Okay. So today we're talking about exponential growth and decay. Exponential growth and decay. So the first question, this is the parent function, right? This is what all exponential functions look like. Cheyenne, what did you say? A is what? Yeah, A is my y-intercept. That happens when x equals what? I cross the y-axis when x equals what? That happens when x equals 0. Guys, we've been working with x and y intercepts since August. Okay. What is another name for A? What else do we call that? Yeah, we call that the initial value. Okay. Let's talk about B. Say that again. Yeah, it's the multiplier when we're looking at a table of values. And it could also be called your growth rate or your decay rate. Okay. We know that growth happens when B is greater than what? When B is greater than 1. And that's because we take the rate and we add it to the number 1. That's what we're going to do. We're going to take the rate and add it to the number 1. We know that decay happens when B is less than 1. So we take our rate and we subtract it from the number 1. That's where those are coming from. That's where those numbers are coming from. Because what is the number 1 in terms of a percentage? 1 is equal to how much percent? The whole number 1 is equal to what percent? 100%. One whole thing is 100% of it, right? So that's why we just take an add for growth or subtract for decay. So x represents our exponent. And in terms of growth and decay, it's typically time. It's typically time. And sometimes it gives you the variable t instead of x. But your exponent is time in terms of growth and decay. Your exponent is time. Okay. So let's look at exponential growth. Let's talk about what that equation looks like. So it looks like this. Y equals A times 1 plus my rate to the power of X. A is my initial value. My rate is a percentage that I make into a decimal. It's a percentage that I make into a decimal. And remember that X is your time. X is your time. How is growth and decay different? What are we doing inside that parenthesis? What is this B value going to do for decay? Well, what did we write up here about decay? Yeah, instead of adding, we're going to subtract the rate. Okay. So Y equals A times 1 minus the rate to the power of X. But everything else is the same. A is your initial value. Your rate is a percent that you turn into a decimal. And X is time. X is time. All right, so I'm going to leave that up there for a second. Let me get the next page ready. All right, raise your hand if you need more time with that. All right, I'm going to move on to the next page. Okay. So let's talk about calculation practice. We are trying to find B. We're trying to find B, which is that value inside the parenthesis. It's either the 1 plus or minus the rate. We're trying to find that. We're trying to simplify that, okay? So the word problems never tell you if you're going to add or subtract. You have to know what they mean by the words that they use, okay? So we're trying to find B. That's the multiplier. Remember that we always start at 100%, and then we add if we're growing or we subtract if we decay. Well, growth can also be a word like appreciate. Decay can also be depreciate or decline. So I want you to know, first of all, some of the words that you're going to see. Okay. So our first example, 12%. I want to take 12% and I need to make it a decimal. Well, in my calculator, I'm going to take 12 and divide it by 100. Javier, I want you to take 12 and divide it by 100 in your calculator. Tell me what you get. 12 divided by 100. Yep, that's exactly right. So this is my rate. That is my rate, because remember, I have to write my rate as a decimal. I just did that. This is growth. So growth means I take 1 plus my rate. So B equals 1 plus 0.12, which means B, that growth rate or my multiplier, is actually 1.12. Okay. We're going to do that with every single one of these on this first section. We're going to find the multiplier, the B value. Okay. So let's look at 7%. 7%. When I turn it to a decimal, well, that's 7 divided by 100. 0.07. This is decay. That means I take 1 minus my rate. So B equals 1 minus 0.07. Yeah, B is 0.93. Is any of this not making sense? I know this is growth because this value is bigger than what? B is bigger than what? 1. This is decay because B is what? Less than 1. Yeah. Okay. That's how this works. Let's look at our next one. 7.5%. Well, that's 7.5 divided by 100. Put that in your calculator. 0.075. This is growth. So am I adding or subtracting? 1 plus my rate. So that's 1 plus 0.075. So what does B equal? Yeah. Is this making sense? Okay, so I want someone to walk me through the 5.9. Someone who hasn't contributed. Hannah, I'm going to put you in charge. 5.9%. What do I do first? It would be 0.059. Excellent. This is decay, Hannah. What does that mean? 1 minus my rate. So 1 minus 0.059. And what does that come out to be, Hannah? What is 1 minus 0.059? Put it in your calculator. 1 minus 0.59. No shout outs. Let Hannah do it. Yeah, 0.941. B equals 0.941. Okay, that's how we do that. That's how we find the growth or the decay value. Okay, so let's start a couple of word problems. So this first word problem, I want you to know that this says decade right down here, and that's too advanced. So I whited out the word decade. You guys just cross it out and change that to say year. I want it to say year. Get rid of the word decade, just cross that out and make it so it says year. The population of a city in 1990 was 1,215,112. The population is growing at a rate of about 5% per year. So let's identify some things we know. What is this value right here? Say that again. The initial value, that's your A. What is this 5%? That's your rate. That is your rate. I need to turn it into a decimal. So 5 divided by 100 equals 0.05. So it says, what is your growth or decay rate? Well, are we growing or are we decaying? We're growing. So our growth or decay rate is 1 plus 0.05, which really is what? 1.05, right? So that's the answer that it's looking for. That's what this is asking. What is B? What is your multiplier? Well, B is 1.05. So if you know what B is and you know what A is up here, can you write an equation for that? Okay, so write it for me, Cheyenne. I think it's 1 million, isn't it? Yeah, 1,215,000 parenthesis. Close my parenthesis. X. Perfect. That is exactly perfect. Okay. So this next question says, predict the population of the city in the year 2000. So this equation started in the year 1990. So that was when time was 0. So in the year 2000, what is my time? 10. Good job. So y equals 1,215,112 times 1.05 to the power of 10. Someone needs to calculate that. Someone needs to calculate that. You all have calculators sitting on your desk. I don't know why everybody looks around the room. Pick up your calculator, put it in there. This is not just a one-person show. You all have calculators. Do it. What'd you get? So we're just going to leave it as 289. Perfect. Okay. Same thing. We're using the same equation, but now we're predicting the population in the year 2005. What is my T now? T is 15. Y equals 1,215,112 times 1.05 to the power of 15. Put it into your calculator. You don't even have to go to the y equals. Just type in 1, 2, 1, 5, 1, 1, 2, parenthesis, 1.05 exponent 15. It's got to be bigger than the first one, right? Because our t value was only 10 in the first one, and now it's 15. I need a couple of you guys to do it. A couple of you guys to get the answer. 430. 2,526,130. Thank you. Can someone else second that? Did someone else get that as an answer? Yeah? Okay. Thank you, dear. Questions? Okay. Flip it over to the next page. Flip it over to the next page. So a sample contains 10,000 bacteria. What is that representing? Yep, that's your A. That's the starting value. After putting on antibacterial spray, is that going to show growth or decay? It's antibacterial. Decay. So this is going to be a decay question. 10% is my what? It's my rate. Turn it into a decimal. 10 divided by 100 is 0.1. 0.1. Okay. So this is decay. That means my rate is 1 minus the 0.1, which means that B equals what? What is 1 minus 0.1 inside that parenthesis? B equals 0.9. So that is my growth rate. And it's not really growth. That's my decay rate, right? Because this is decay. It's less than 1. All right. So we know A and we know B. Jordan, tell me the equation. Starts out with Y equals. What's your A value? Yeah, to the power of X. Very good. Thank you. That's awesome. Good job. Okay. If this pattern continues, how many bacteria will there be after 3 hours? So that means we're going to let T equal what? Yeah, which we can call it X as well. Time. Just the time is 3. So let's see. Y equals 10,000 times 0.9 to the power of 3. Okay. Perfect. Thank you, ma'am. Our next question says, what about after 1 day? What? T equals 24. Good job, Cheyenne. We had to talk about that last period. So Y equals 10,000 times 0.9 to the 24th. I don't want any shout outs. I want everyone to do it in their calculator. Don't say the answer. Everybody do it in their calculator and write your answer down on your paper. Just round to the nearest whole bacteria. Round to the nearest whole bacteria. Put it in your calculator. Let me know when you have it and I'll come check. No shout outs. Dude, you're just type it right in your calculator. No Y equals or anything. Just show me on your calculator. Perfect. So what are you going to write that as? So if you round it to the nearest whole bacteria, like no decimals. Right? Perfect. Good. 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 Well, figure it out. I mean, we've been doing it over and over and over again. So I want you to put it in there. Yes. Good job. Perfect.
Ours is good.
Perfect. Excellent. It's a carrot button. X. Right there. But what is that? Sorry. Put it in there. What'd you get? Calculator. Let's go. Type that equation in there. Perfect. Okay, so what do we get, guys and gals? 798. Next one. Your starting salary is $35,000 per year. What does that represent? Your initial value, A. God bless you. You get a 5% raise every year. How do we show 5% as a decimal? 0.05. Is this going to be, if we're getting a raise every year, is this growth or decay? Growth. That means I'm going to do what? 1 plus 0.5. 0.05. So what is 1 plus 0.05 come out to be? Yeah, B equals 1.05. So write the equation, Olivia.
Y equals 35,000 parentheses 1.05 parentheses power x.
Perfect. To the power of x. That's excellent. Okay. How much would you make in your second year with the company? So T equals 2. And our equation is Y equals 35,000. 1.05 to the power of 2. And what did you get, Olivia? Good job. Okay. What about after 10 years? No shout outs. You guys figure it out. Y equals, no shout outs. I'm going to come around and check 35,000 times 1.05 to the power of 10. Raise your hand when you've got it. Just solve the equation. So 35,000, 3500, one more zero. Parentheses, 1.05. Parentheses, caret, to the 10th power, 10. Perfect. Write that down. Okay, solve that one. Let me see it. Good job. Perfect. 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 Good job. Good job. Perfect. Awesome. Awesome. All good up there? Does everybody understand how to do this? Yes? Okay. So go ahead and staple